Full show. This is Zugole Tumdudu from Cape Town. I was doing my grade 12 last year and I'm going to upgrade on November. So I need your assistance here with Euclidean geometry here.
Cut your fro, honey.
Wow, honestly.
Right, awesome stuff, awesome indeed. Let's go right into this question and check without any further waste of time so that we can have access to even more questions that are coming from you guys. Let's check the question together. It says here, in the diagram, ABCD is a cyclic quadrilateral. Okay, fine. So we can clearly see that those 4 points there, or those 4 vertices, lie on the circumference of the circle. It's a cyclic quadrilateral, such that the line AC is perpendicular to the line CB, and DC is equal to BC. So DC is equals to BC. We can clearly see it is labeled on the sketch. The love letter is important. You check if the information on the love letter does appear on the sketch. If it doesn't, then you must populate your diagram. All right, AD is produced to M such that AM is also perpendicular to MC. You can see the 90s there, guys. So it becomes very easy for us to work with this. Is 90 degrees here, and it is also 90 degrees right there. We're told that angle B is equal to X. Let angle B equals to X and prove that. All right, first question, we need to prove that MC, the line MC, is a tangent to the circle at point C. Right, we want to prove that the line MC is a tangent at that point. Now, in order to prove a line is actually a tangent, you guys need to understand the theorems that are related to tangents from your grade 11's knowledge. There's 3 of them. Line from center is perpendicular to a tangent. Secondly, the tan chord. Thirdly, 2 tangents from the same point are equal in length. So it's got to be one of those 3. Once you have proven any of those, then you can claim that that particular line happens to be a tangent. Okay, cool. So let's see how we can do this one. Now, by just looking at it, you can clearly see that we don't have 2 lines that can possibly be tangent. We don't have the center to say a radius is perpendicular to a tangent. The only thing that we can claim to try and prove here is converse of the tan chord. If I can prove that the following is the case, if I can prove that the angle between the tangent and the chord is equal to the angle subtended by the chord, then that will be conclusive proof that this line that is lying there, which is in this present question, and the line MC, we can then conclusively claim that that line is a tangent. So let's see what we know so far. Angle A2 is equal to 90 degrees minus X, because in this triangle, clearly we can see that we've got 90 and X. We are looking for angle A2. So I'm going to start there and saying angle A2 is equals to 90 degrees minus X. Where am I getting this? This is sum of angles of a triangle. Sum of angles in a triangle add up to 180. So that's going to be 90 degrees minus X. Right. However, chord BC is equals to chord DC. So clearly this angle A1 must also be the same as angle A2. Right. But angle A1 is equal to angle A2 is also equal to 90 degrees minus X. Why am I claiming this? This is because of the fact that equal chords in a circle will always subtend equal angles. Equal chords will always subtend equal angles, Zugo, and I hope you can be able to see that. If this is 90 minus X, this is also going to be 90 degrees minus X. So now my goal is just to prove that angle C2 is also 90 degrees minus X. If I can do that, then I will have succeeded to prove that MC is a tangent. However, let's check now what is going on. You will agree with me that angle D2 is the exterior angle of this particular cyclic quad that we are looking at right now. So which means angle B will be equal to angle D2, right? Because of the fact that angle D2 will be equal to angle B, and it is because it is an exterior angle of the cyclic quad, will always be equal to the interior angle which is opposite. It's always equal to the interior opposite angle. So that means that angle D2 will also be X. Let's put that X on the sketch. So this angle is also equals to X. Therefore, we can then conclude that angle C2 will also be 90 degrees minus X. This is because of sum of angles of a triangle, or sum of angles in a triangle will always add up to 180. Now that means that angle C2 happens to be equal to that angle A at the top there, which is angle A1, right? It is equal to angle A1. Therefore, MC is a tangent and the reason is of the following. It's converse, right? The opposite of the tan chord theorem, right? Converse tan chord theorem. Once we have proven that this is the case, then we can be able to make that particular claim. This angle is equal to that angle. They are both equal to 90 degrees minus x. So this line MC definitely has to be a tangent in this question. Moving right along to the last part of this question, we now have to prove that ACB is similar to CMD. ACB is similar to CMD. Those are two triangles, guys. When you want to prove that two triangles are similar to each other, one triangle has 3 angles, the other one has 3 angles. If you can prove that those angles are equal, those two triangles have got equal angles, the corresponding angles are equal, then those two triangles are going to definitely be similar to each other. And that is basically what we want to do. Okay, cool. Let's see if we can be able to achieve that. Now, don't forget what we have already found. We found that this angle is 90 degrees minus x. We found also that this D2 here is x. We found that this one is also 90 degrees minus x. All right, so I'm looking for 3 things in those two triangles that I can find that are going to be equal. So in these triangles, in triangle ACB and triangle CMD, we want 1, 2, 3 things. In this case, 3 angles. We have to prove that the corresponding angles are equal to each other. Once we can do that, then that will be conclusive proof that those triangles are the same. All right, let's check now. Angle A in the first triangle, which is angle A2. Angle A2 is equal to angle C in the second triangle, which is angle C2. And this information has been proven in our above calculation, the one we just did in number 1. And then the second part now will be proving that angle C of the first triangle, which is ACB. So ACB is equal to M in the second triangle, right? In this triangle that is lying low right there at the bottom, the one I just highlighted in yellow, is equal to angle M, and this information has been given to us because both of them are equal to 90 degrees. And then lastly, we can clearly see that since we have done what we have done, then the third angles are definitely going to be equal to each other. I can even go and say angle D2 is equal to angle B is equal to X. And this is also proven from the previous question that we did. We did prove that they are both equal to X. Therefore, we can then conclude that triangle ACB is similar to triangle CMD. And always remember to put the reason why you always say what you said there. Angle, angle, angle. And this is basically how you need to approach theorems, or questions that involve proving that two triangles are similar to each other. Just prove that the corresponding angles are similar to each other.